How you guys doing? This is Dola. In this video, we will talk about how to or I will demonstrate and show you how to create a symbol. So for creating a symbol, you'll need to have the schematic first, which we did, and we will create the symbol. And because the symbol is actually a better way to build much more larger circuits than the one we built previously, which is the inverter itself. Imagine building multiple inverters, and I'm talking about like hundreds, maybe thousands of inverters connected to each other, which is really most of the chips today have lots of inverters based on their application. So just putting in MOSFETs and using them as the circuits and connecting multiple inverters just with these MOSFETs might get hectic and might be a hassle for people to read the circuit or the schematic itself. So what we'll do today is I won't go through the same cell view, but I'd rather create another cell view. And I'll show you the process of doing that. So for this one, we will do an inverter symbol. So for now, once you're inside the VLSI test library, go to File and then New, and then Cell View. And this window will pop up. Inside this window, let's call this inverter 1X or X1. You know what? Let's call it 1X. And then this is the name of the cell. It will be schematic. And let's click on OK. So this will open the schematic. We already know this. So here you have it. The schematic window opens up. Let it load the stuff behind. I think we're ready now. So let's just maximize this. And now let's go ahead and insert the MOSFETs that we already did this. So I'll just go and do it real fast. NMOS 1B, insert that, go back with Alt Tab, PMOS 1B, tab, and then insert that as well here. And then I didn't play with the width and the length. So because it's a minimum device, minimum driving inverter. So I'm creating the wires now here. Instead of creating another wire, I'd rather copy this. I already showed you the functions of, or the hotkeys. I told you how to create wires and connect them. Now it's time to label these. So I will label each one of them in, out, VDD, and ground, exclamation mark. So in, out, VDD, and ground. Now, one more thing, in order to make this a symbol, all you have to do is press on P. So P for pins, and this window will pop up, and you'll have to name the pins of this circuit. So in our case, we have one input, one output, and the rest are IOs, so input outputs. So let's name these one by one. So in our case, we have in as an input. Its direction is input. The usage is schematic. The signal type is signal. So under signal type, we have multiple categories. So we have ground, we have power, clock, whatever the circuit has as an input, you should, well, normally what I do is most of the time I go between these five, but in the digital circuitry case, what we have is power. We sometimes have clock based on if you are creating a flip-flop or a latch circuit. And power is obviously the VDD, or the supply voltage of the circuit. Ground is ground. And the signal is, it could be anything that is inputted to the circuitry. So in our case, it's input, but in other cases, you might have multiple inputs. So you'll have to name all of those or define the direction of all of those as inputs and the signal type as signal. All right. So in our case, the input is signal, and that's about it. And we will do hide, and then come here, place the pin. Let's do for every pin before we connect these to the wires. So again, P, and this time out, and we'll choose output here. And then we'll have to choose this as the signal. The output is a signal as well. So hide, place this here, go back to P, and then for this one, choose, actually, I want to show you this. So let's just say VDD, right? Type in VDD and label it like that, and then press on tab. You can see here that the signal type automatically changed from signal to power because Cadence recognizes this as a power type signal. And in our case, the direction for the VDD, which is, it's always considered input output, because it's an IO. And we'll just go ahead and place this here. Go back again. Now we'll do for the, you could do for ground. You don't have to. When this is stated as, or defined, when the label here is defined as ground exclamation mark, you don't have to place a pin for this. And you know what? I'd rather not place a pin here. Sometimes you could, but it's an extra pin to connect in the symbol or in the circuitry where you're using this symbol. So we'll just go ahead and place these, and then hit escape, and then hit the check and save marker here. And then you got, it says 2 warning. So realize that I forgot to connect the bulk terminals to whatever it should be connected to. So close. What I'll do is, so for PMOS and digital circuitry, it's always connected to VDD. So I'd either do this, but I'd rather not. In my case, I always do this. So I take, actually, let's just connect another wire here. Copy this because we have to connect the bulk terminal here to ground too. So what I do is I copy these wires, connect them to the terminals here, and then I do label L for label, and then type in VDD and then GMD exclamation mark. So connect these two to the wires, label these wires, and then we're done. That's basically it for the inverter. And let's just check and save to see if we have any other warnings. No, and you can see the warnings just, they went away. So now what we need to do is connect the pins, connect these pins here, and one here. It kind of shows like it might not be connected, which is obviously might be wrong. Just in case you want to make sure if this is connected or not, what I do is press on M for move, choose the pin, try moving it around, and you can see that there is a dashed mark. So this tells you that this pin is connected. And what you want to do is just hit escape, and that's it. If you want to make sure for the input and output, if they're connected or not, do the same. So select the pins, move it around. You can see it's connected. Escape. This one. This is not the case all the time. You don't have to make sure all the time. It's my habit to make sure. So hit check and save. Now we have the pins connected to the circuit. And the next step here is to hit create, and then cell view, and then cell view from cell view. So it will pop up this window, So cell view from cell view, library name, VLSI test. Cell name is inv1x, just as we named it. From view name to view name symbol, tool/data type should be schematic symbol. And that's about it. I don't change anything here. I just view it and then click on OK. And this will pop up another window. And this is the symbol generation options window. And it will show you whatever the symbol is, where do you want to put these terminals, or basically the pins of the symbol. In our case, so what Cadence does, whatever you type in here, so for bottom pins, we don't have any because normally we would have had the ground pin, but in our case, since I made the ground global, so you don't need to put in a pin, it doesn't show up on the symbol generation options. But here you have the left pin is in, the right pin is out, and the top pin is VVV. So what we'll do is just click on OK. But in any other case, let's say you put in multiple inputs. This might show up as, it would show in, maybe inside the right pins blank. And what you would do is copy that or cut it and paste it inside left pins, in case you need a specific type of configuration. This is not really significant. So what we will do is click on OK. This should open another window, but we'll have to wait. So this window popped up, and this is the symbol editor window. So as you can see, the left pin, top pin, right pin. So these are the pins of the inverter. So click on the square, maximize it. So in our case, we are building an inverter, right? So the symbol of the inverter is a triangle and a circle on the right side. So what we'll have to do is we'll have to delete these stuff, or maybe move it around, because they are sometimes important. So I want to move this. It might be hard to move it around. So what we'll do is we'll delete this square. Keep the pins. Watch out. Do not delete the pins. Keep the pins around here, or the terminals. So this, press on M. So I just highlighted, and then pressed on M for move, highlight, press on M for move, keep it like that. So now I could easily move this around. So I moved it here. Now what I want to do is I want to create the inverter. So for now, let's make it more smaller maybe. This is where your drawing skills come to hand. So I drew a triangle. I hope it looks like a triangle. I'm not sure. And the next step is to create maybe here, a circle, which is the inverter circle. And the last step, I like to move this a little bit here. Move the whole pin a little bit closer to here. So this is VDD, and we got the in, and we got the out. Whoop, whoop. Highlight, click, move here. Now some of you might not like how the out, or some of these labels are inside or behind other lines or words. So in this case, you can actually move this to be here, this to be here. I don't see any overlapping here. So what I'll do is just bring this down here, the part name, and maybe leave this here. Yeah, I mean, it looks fine right now. So maybe bring this a little bit here. Yeah, that's about it. So now after you're done with this, move this square around make it so it overlaps the red squares or the terminals of the inverter. So in this case, I'm just overlapping them, and I'm trying to cover the whole circuit or the drawing itself. So that's about it. And you got to bring this instance name as much as close, whatever you want to place it. And now these two are not that significant, but in the case where you create inverters with different configurations, this might be different widths, different length, different driving, I want to say driving strength. I'm not sure if that's the correct term. But in any case, you could just place these. These are important in the case where you create multiple configurations of inverters. It might be a buffer, it might be a 3 inverter connected in series. So in this case, the part name comes into hand. But for now, yeah, I placed it here, placed this one, maybe down here, yeah. All right. So as soon as you're done with this, all you have to do is just save them. And that's it. So check and save, make sure. And that's about it. Now, when you're done here, you don't have any warnings or errors. All you have to do is close this and close this. Now I want to show you something, and this is just a test. You don't have to do this. But yeah, let's go ahead and do cell view test symbol. And this is not something I do all the time. I just want to show you how things look when you do a symbol, create a symbol. So create a new schematic. This is a temporary one. I'll delete the cell view after I'm done. So for now, press on I for instance. Now go to, click on this, go to VLSI test, go to imp1x, this is where we created the symbol, and you got the symbol. Now you could place the symbol wherever you want to, easily, without the need of putting in MOSFETs all the time. So this is what the symbol comes in hand, where the symbol comes in hand. You could use the symbol like much, place it, play with it, wherever you want to do with it. And it's a much more simple way to create circuits with larger and more complex circuits with larger elements or much more elements. So as an example, I want to show you this, and this is, you might not use it, but in the future, if you're in this field, it comes in handy. So for example, click on this and then click on or press on space. And once you do this, the labels come out by itself. And this is a nice shortcut, but it's not that used much often. It's not it comes handy at some point, but not all the time. Another thing is, let's do undo with U. So that's some applications require like stage buffers. Oh, I just moved it. I want to copy it. So what I do, for example, I want to connect multiple circuits all together. This, and maybe, there's no need. So what I did is connected 2 inverters, right? And you have a series of inverters, you want to build that. So look at this. I mean, you just build 4 inverters really easily. In the other case, you would have just inserted multiple MOSFETs all the time. Maybe copy the MOSFETs. I mean, yeah, it's all right, but in terms of graphical complexity, yeah, things become more hectic. So another thing is, yeah, I didn't connect these, but I mean, let's try this. I want to highlight all and then press on space. Yep, and that's what happened. It just created the symbol, the labels by themselves. But see, this is the problem when you press on space. You have all nodes connected to each other, which is wrong. I don't want all nodes to be the same. So undo. So that comes in handy only when you want to build much more inverters. So that's about it. This is for symbols. For the next part of this video, we will talk about layouts. I will build a layout, and then I will do or maybe just build the layout. And the video afterwards, I will go through the DRC, LVS, and the QRC extraction, or in other words, the RC extraction or the parasitic extraction.